This time, we will discuss the environment sets. These are the default settings you can customize and save to have them when working with other files. Nearly all aspects of the FluidFlow application can be configured and customized. The configuration settings that you change are saved so that each time the application starts, your own preferences are applied. Some of the configurations will be familiar, such as changing the position of toolbars, adding buttons, etc., because these customizations are commonly found in professional software. Some aspects of the environment are stored as a subset called an environment set. You can make as many environment sets as you need, change between them interactively, and use them for future models. An environment set is closely associated with the default input data and units for every component that is available from the component palette. It also includes how and what calculation results you wish to see. When trying to create a new environment, we start with two default environments upon installation, which are System International and US Basic. These selections can be found in the Options toolbar. These default environment sets are the primary basis for creating customized environment sets. Rather than making the changes to any of the basic sets provided, it is a better idea to make a renamed copy and make the changes to the copy. From the Options menu, under Environment, we can save this environment under a new file name for further customization. For the demo, let's save our environment set as Environment Set Demo for its file name. We will be storing the changes made on the software environment with this file in the ensuing discussions. Each environment set stores the following information and can be easily accessed through these function keys. F4 accesses default settings for each component available from within the program. Let's show an example of changing a component to fault for steel pipe. By default, the input data for a steel pipe is a length of 10 meters with schedule 40. We'll change this default value to 20 meters and change the pipe schedule from 40 to 5. Now that we have it set as the default, we'll create a new steel pipe. Notice that the default length is already 20 meters and with a schedule of 5. F5 accesses data columns you wish to export to Excel. Shown on the default for the steel pipe are input parameters unchecked. Thus, when we try exporting this in Excel, as shown in the demo, we can observe that only the checked calculation results are presented and are represented by the purple columns. Now, let's try changing the default settings and checking the entire input block to modify the data to be exported to Excel. When we export the data to Excel, notice what happens to the steel pipe information. There are already green columns that represent the pipe input data. Moving further to the right are the previous purple columns showing the configured results data. F6 sets up flyby options. This is the window that appears as you move the mouse over a component on the active flowsheet. It is possible to set the flyby content for each component. As shown in the steel pipe flyby, the input parameters are unchecked, so when navigating through the flowsheet, these are not shown in the flyby. We will configure the flyby setting to include steel pipe input information as an example. Now that it has been set up, it is evident that the steel pipe flyby has increased in size since the input information has been added and is already shown. F7 provides access to the columns you wish to print in your report or export to Word or HTML. Similar to the F5 function, we can recreate exporting options to MS Word or HTML files using this function. F8 configures the contents of the table shown on the Results tab of the Data palette. Let's consider again the steel pipe component as an example. Here, I had deliberately configured it to show only the element type and deposition velocity in the Results tab. By pressing F8 or via the Options menu, we can check individual parameters or the entire block of parameters for the steel pipe results. As random parameters on this dialog box are checked, it can be observed that, aside from the element type and deposition velocity, other clicked parameters are also shown in the Results tab. F9 individually sets the calculated result units and the number of decimal places you wish to show. Also, we can use this option to modify units for gas volumetric conditions and solids-based preference. Let's use the pump component for demonstration. Remember that currently shown is NPSH available expressed in meters of fluid and with only one decimal place. Through F9 or the Options menu, we will express this figure in feet of fluid with 3 decimal places. Now, shown on the Pump Component Results tab is the NPSH available, expressed in feet of fluid with 3 decimal figures. When all the preferences for each environment information have been established, users can save these settings as their own environment set, which can also be used in other future models. In this example, the configuration is made with a model already available to aid explanation. However, users can establish their preferred environments at any time, and even as they start building their own model. After this, you can customize your preferences for some default settings, save them, and have them when working with different files. These settings include units, decimal places, default input, and some more. In the following video, we will see the customizable parameters from warnings and hints.